everyone. Welcome to Learn to Rank hands-on session. In this session, we will walk through the steps to train a generalized deep mixer model using two open source libraries, Gdmx and dtext. The prerequisites for this session are: have Docker installed on your laptop or desktop. You will need internet access in order to download images from Docker Hub. And you need to run the docker run command to launch the container for this tutorial. Then type localhost, port number in browser to access this notebook. The outline of this session is Introduction of Generalized Linear Mixer Model, short for GLMix, and the Generalized Deep Mixer Model, short for Gdmx. We will cover how to download movie lens data and pre-processing it for following GLMix model and Gdmx model training. Next, let's go to the first section, Introduction of GLMix and Gdmx. A couple years ago, LinkedIn started promoting GLMix model for our recommender product, such as job you might be interested in, and it has been proved quite successful. For problems such as predicting the response of user I on item J, GLMix model will consist two or more models, with the first model is called global model, which trained coefficients for all features, and a couple of other models. We call it random effect models. In this example, both the per user and per item are random effect models, which train coefficients on different granularity or dimensions. This will help to capture more signals that may be drawn in the all features. Take movie lens, for example. The global model will be similarity between user features and movie features. The per user model, however, will capture a personal preference. For example, if a user liked a comedy movie, we will likely to boost the comedy movie more in the user's result. Similarly, for per movie model, if a movie is liked by a female user, we will boost this movie more for female users. If the GLMix works well, why we move to Gdmx? The reason is GLMix, especially the global model, may not be able to capture the non-linear features between user and the movie in our example. So we extended to support deep neural networks to extract hidden features between user and movie. For example, the hidden features between user text review and the movie text description. This actually is very similar to the wide and deep learning for recommender system from Google. For the Gdmx workflow, we train global and a couple random effect models sequentially. When the global model is trained, it will scoring all its training data, whose score will be passed to the next model as an offset, and the model will extract more features, more signals from the residuals. So different models, different random effect models will capture different signals in different granularity or dimension. Next, let's go to the data download and the pre-processing section. We will start downloading the movie lens data. Movie length is a 5-star rating and a free text tagging activity from Movie Lens, a website to recommend movies. Let's download it. As you can see, it actually has a couple of files, and each file corresponds to one or more features. We will train 3 models in today's section: global, per user, and per movie. Next, let's prepare features for each model. We will need those packages for today's session. We will also need to define the input directory and output directory for the data preprocessing. Here's features we specified for different models. For example, Dora is used for movie features, and the user features will include age, gender, and occupation. The combination of user feature and movie feature will become the global feature. We will also indexing them. Next, we will need to define a feature tensor metadata for each model. For audience who are familiar with TensorFlow, this is used by TensorFlow dataset APIs. So it knows whether what's a data type of this feature and whether it's sparse or not, sparse tensor or not. Here are a couple of utility functions to help us to pre-processing the data. We will go through some of them, but for more details, please go through the code. Those code are pretty explicit and self-explained. Here's the main code we do the data transformation. We will use data. We will use pandas to read the data and then pre-process the data. Let's see what we are doing in the pre-process data function. We will do normalization for a few features such as release date and age. We will also binarize the scores. We use 3.0 as threshold. So if the rating is higher than 3, then the response will be 1, representing good. Otherwise, it's bad. And next, we will to define features for each model. And next, we will tensorize the data so that the data can be later can be serialized. We'll also need to split the data set into training and testing. The last step is to serialize data to TensorFlow, to TF record. We'll also need a metadata for the Gdmx training. Let's running the serialization first. It may take a while. And then we can take a look at all the producing data set and the metadata. So this movie length is the output of our data preprocessing step. So we can see there are three subdirectories: global, per movie, and per user, which corresponds to the data or metadata for the training of each model. Let's take a look at the metadata, the tensor metadata. This defines the features and also a couple of properties that can be used to deserialize that by TensorFlow APIs, dataset APIs. And we also will have the number of training samples here. We also can take a look at the feature list. This is the feature list for the global model. As we can see, this is corresponding to the fields from the data, which corresponding to three columns: the age, gender, and the occupation. Next, we will show how to train a Gdmx model using Gdmx. We will need to create a Gdmx config file. Gdmx config file specifies configs for the fixed effect and the random effect model training. And more details can be found on our GitHub page. Let's take a quick look at the config. The config is a JSON format. As you can see, the parameters actually is self-explained. We will define the output directory, which will read the data and output model or intermediate data into this directory. And for fixed effect config, we will define the model name, action, we'll have train and inference. So if you already have a model, we can help do the inference for you. And we will need to specify the train data and the validation data set. We have already done that in the data preprocessing part, so we just put in the path here. And here's the feature list. We will need that for inference. And here's the metadata of the training data set, or training and both training and testing data set. And here's the optimizer we will use. We use LBFGS. And here's also a couple of fields like L2 regularizer weight and regularizer BIOS or not. The random effect config is very similar to the fixed effect config, but there's only one or two fields, I believe. For example, here is the partition entity. Partition entity is used to partition a data set. So for each user, we will train a model for him or her. And also here's some configurations that helps to optimize the training speed. We have random effect is a list of config. So in our example, we will train two random effect model, which is per user and per movie. So we have two configs for them. We will write it into a file. And next, we will just use the Gdmx workflow to train the three models sequentially. For the single worker case, we only need to provide the config path to the file. It will start training the model, the three models, the global, per user, and per movie sequentially. As we show earlier, it corresponds to the jobs here. So it first will train a generalized linear model for the global, and then compute the matrix using a Spark job, and then do the partition based on the user ID, and then train a per user model for each user, and then it will repartition the data set by movie ID and train a per movie model. The training may take a while, depends on the hardware on your laptop or desktop. So the Gdmx workflow provides end-to-end service. So basically, you only need to specify the config file. It will connect all the steps for the fixed effect model, and the random effect model. So the fixed effect training is done. This is output from the LBF.js solver. So it computes the global model, the metrics from the global model. And those are the output from the Spark job. We also have support for distributed training. We use a open source framework called Workflow from Google to support the distributed training. Basically, Workflow is a framework built on top of Kubernetes. So it can utilize Kubernetes to schedule resources for distributed training. Here in this demo, we just use single worker to do that. Okay, so we can see the training has been finished. So this is the output directory we defined in the config file. So let's take a look at all the structure of the output file. So there are same as the results of the pre-processing. It has 3 subdirectories: global, per movie, and per user. Each has a models directory, and the training scores, which is the score from training data, the validation scores, the scores from validation data sets, and also the metrics or from the validation data set on the given model. Remember, each model is kind of based on the results from the previous model. So let's take a look at the results. So we can see the random effects model, the per user and the per movie model actually improves a lot from the global model. And it basically captures more signals from a subset of the features.